Welcome to another GL Communications product demonstration video. In this video, we will demonstrate the tProbe, which is our versatile hardware platform for analog, TDM, and Datacom telecommunications testing. The tProbe can analyze and emulate voice, data, fax, analog, and digital signals, including echo and voice quality. The tProbe has many interfaces, including two T1E1 ports, two voice frequency or VF ports, an FXO and an FXS port, and two Datacom ports. The tProbe is controlled by a Windows PC via a USB cable. It is designed for easy portability, visualization, and automation. TDM technology uses time slots. T1 has 24 time slots, and E1 has 32 time slots. The time slots can carry various traffic, including voice, digits, tones, fax, modem, and digital data. In this simple demonstration, we will explore the T1E1 ports on the tProbe. Specifically, we will connect the two ports with a T1E1 crossover cable. We will start by conducting a bit error rate test on all time slots in both directions simultaneously. Then we will send and receive tones, digits, and voice files. This is the main tProbe graphical user interface. The first thing to note is the alarms. The tProbe will display any alarms for both port 1 and port 2. You can see things like the synchronization loss, any bipolar violations, carrier loss, and so on. You can also see T1E1 statistics such as the frequency and the power level. Let's run a bit error rate test. Click Intrusive Test, Bit Error Rate Test. Then select which card to send the bits from. We'll select card 1 to start. So we're now sending a bit stream from card 1 to card 2. We're sending the bit stream over all time slots. Let's now monitor the bits being received on card 2. Click Monitor Byte Values. Then select card 2. Notice that all of the time slots are receiving data. If you wish to see the binary values, simply click Monitor Binary Byte Values. Then select card 2. Now you can see the individual bits being received on each time slot. You can also monitor things such as the signaling bits, as well as the power level, the DC offset, frequency. To see a more visual display of the bit streams, you can select Monitor T1 Data as a real-time bitmap, then select card 2 and select Play. So here, 1s are represented by black dots and 0s by white dots. You can also see the bit stream across all of the time slots. If you click Monitor Time Slot Window, this offers another way to see the hexadecimal data across a given time slot. So for instance, on card 2 time slot 0, this is what the hexadecimal data looks like, and to refresh, hit New Buffer. Under Monitor, you can click Oscilloscope, which will give you a real-time view of the signal on a given time slot. We can also look in the frequency domain by clicking Monitor Power Spectral. So now let's go back to the bit error rate test. We're already sending a bit stream from card 1 to card 2. Now let's send a bit stream from card 2 to card 1. So here we see that as soon as I start sending the bit stream from card 2 to card 1, the status of the bit error rate test in both directions is pattern synchronization. There are no bit errors in either direction, and as mentioned before, there's no synchronization loss or bipolar violation. Now, to see what these type of errors would look like, you can simply insert an error, and if you insert an error from card 1 going to card 2, you notice that the total errors is now 1. And similarly, if we insert an error from card 2, we notice that the error is picked up on card 1. We can also insert bipolar violations, and in doing so, note that on card 2, we saw that the alarm went off showing the presence of a bipolar violation. H means it's now in history, it's not actively happening. We can also see the presence of the bipolar violation in the statistics for card 2. If you are having problems with sync loss or bipolar violations, you can examine the pulse mask by clicking Special Applications, Physical Layer Testing, Pulse Mask Display. The pulse mask program looks for an isolated pulse among a string of zeros and captures, digitizes, and displays it for compliance. Now let's stop the bit error rate test and instead focus on how to send tones. Click Intrusive Test and then Transmit Tone. Let's transmit a tone from card 1 at a frequency of 1004 Hz. Let's select the time slot to be time slot 0. Go back to the Transmit Tone tab and simply click Send. Now notice that in the oscilloscope it picks up the 1004 Hz tone. This can also be seen in the power spectrum, which has a peak at 1004 Hz. Now let's demonstrate how to send digits. Under the Special Applications menu, select Dial Digits, and then select Transmit Dialing Digits. Select what type of digits to dial, and then input the digits. In the Setup tab, you can select which time slot and which port to transmit the dial digits from. Notice that we have the oscilloscope and power spectrum set to port 2, time slot 0, so that we can detect the incoming digits. Under the Dial tab, simply click Call. Now let's demonstrate how to send and receive audio files. Click Special Applications, Record Playback File, then select Playback File. Select which port you want to transmit the audio file from, as well as the time slot. Then browse for the file. Then click Start. Notice that port 2 detects the incoming audio. You can also play back the audio through the speaker on the tProbe by checking Speaker and selecting Card 2, time slot 0. Thank you for watching. To learn more about the tProbe or any of our telecommunications testing solutions, please contact us. We look forward to hearing from you.